Welcome to Reliability Matters. This is episode number 32 and the first episode of 2020, so let me say Happy New Year. I would like to thank all of you who listen to this podcast, and especially those who reach out to me with comments and questions. Most importantly, I'd like to thank my guests who make this podcast possible, interesting, and valuable. Without them, this podcast would certainly not exist. A few listeners have asked me about my background. Well, this show is not about me, rather it's an opportunity to ask subject matter experts relevant and topical questions as they relate to reliability. Here's a little bit about me. I began my career in the electronic assembly industry in 1985 when I was 24 years old. In 1992, I founded Aqueous Technologies, a manufacturer of cleaning and cleanliness testing equipment for the electronic assembly industry, where I remain its CEO. My passion is education, providing information on best practices for the electronic assembly industry. While my background is in cleaning and cleanliness assessment, there are so many other processes required to build a reliable electronic assembly, and each of them has a unique best practice standard, which is the reason for featuring guests on most episodes. As this new year begins, I'm grateful for my audience, I'm grateful for my guests, and I'm grateful for the sites that syndicate the show, including Circuit Assembly's PCB Chat. Thank you, Mike Buto, for running the show at pcbchat.com, and Ascendo Reliability at reliability.fm, who airs this show and many other similar shows on the subject of reliability, all curated by Fred Schenkelberg. So with the thank yous out of the way, I'd like to wish everyone a happy and prosperous new year. Now, let's get on with the show. My guests today are experts in stencil manufacturing and soldering materials. Greg Smith has worked in the electronic assembly industry since 1989. He was the owner of a stencil manufacturing company for 23 years prior to joining Fine Line Stencil. After the merger of Fine Line Stencil and MET, he became the manager of stencil technology for Blue Ring Stencils. Greg writes and presents white papers, works with customers on stencil design, and performs root cause analysis to improve customer yields. Tony Lentz, my other guest, has worked in the electronics industry since 1994. He entered the industry as a process engineer at a circuit board manufacturer. In 1999, Tony joined FCT Companies as a chemical laboratory manager, production facility manager, and most recently, a field applications engineer. Tony is focused on field application and R&D for FCT Assembly solder and stencil products. Tony has extensive experience doing research and development, quality control, and technical services with products used to manufacture and assemble printed circuit boards. He has published many papers at industry events and given many presentations at those same events. Tony is a speaker of distinction with SMTA. Tony holds both bachelor's and master's degree in chemistry. Today we'll be discussing voiding, a real concern for modern circuit assemblies, especially within the LED and automotive electronics space. Greg and Tony recently published a paper presenting specific techniques to improve yield and voiding. And they're my guests today, next on Reliability Matters.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome to the show today, Greg and Tony. Thanks for being my guest today.
Thank you for having us on, Mike.
Well, my pleasure. So, Tony, you and I know each other because we've done workshops together where you've been a speaker, I've been a speaker. And Greg, I think I've met you several times in trade show environments and symposium environments, but I don't think we've actually worked together before. So thanks for joining this team of talkers here.
I'm excited about being here.
Good. So I read an article through LinkedIn, actually, which was entitled Root Cause Stencil Design for SMT Component Thermal Lands. Not exactly the most exciting title. If you're outside of our industry, right? We all appreciate titles like that. But if you're a civilian and you're outside of our industry, I think we lost them on the third word, right? Same as my articles. There's just no way to make them sound exciting. But the content of the article, if you're in the electronic assembly industry, was actually quite exciting. It was really about improving voids and techniques. So before we go down that rabbit hole, let me just say a few things. From my perspective, when it comes to reliability of solder connections, there are at least two factors that affect reliability that land exactly in your worlds. One is the stencil, of course, and the other is the material that we squeeze through the apertures of the stencil, namely solder paste. And one of the major topics in the reliability world is voiding. Some say that the voiding concerns may be overrated. In fact, I've had some guests on this show kind of go off on that subject, like, we're paying way too much attention to voiding. We don't need most of the solder that's under the lands, et cetera, et cetera. Alternatively, whenever I speak with someone from, for example, the automotive electronic space, I hear quite the opposite. I hear that voiding is a major concern because of the high current, high voltage running through these terminations. So do either of you want to throw your hat in the ring? I know you already have, but do you want to throw your hat in the ring on this conversation? And first of all, what's your take on voiding? Is it overrated? Is it underrated? Is it both? Whoever wants to jump in, go ahead.
Well, Mike, I agree with both sentiments. Actually, I've heard it both ways as well from our customers. Some customers believe that, voiding's always been there. It probably will always be there to a certain extent because it's very difficult to eliminate it completely. And now we just have the tools. The X-ray systems are readily available in order to see the voids. And so we're just now inspecting more frequently for them. So now it seems to be more of a perceived or manufactured problem. But like you said, there are sectors of our industry, like the automotive sector. I've heard the same thing with LED lighting, where the heat transfer out of that component is extremely important, and voiding can interfere with that. And in some cases, it can cause a failure of the component due to overheating.
It's funny you mentioned LED lighting. I have a pet peeve with that industry. When LEDs first came out on the consumer market, for lighting, they were very expensive, but the promise was that they would last, 100 years, a billion years, 20 years, whatever, certainly longer than an incandescent light bulb. So I started switching all my lights out, my landscape lighting and my indoor lighting and whatever, to LED many years ago before it was trendy to do that. And I had the worst experience with LED lights. They would last less time than an incandescent bulb. And of course, you throw away your receipts because you just walk out of the store with this confidence that you just paid $20 for a light bulb. It's going to last you, the rest of your natural life. And I've just had terrible experience with it. And then I've sat through some symposiums where the speakers were talking about the whole LED technology. And yeah, they built LED lighting wrong for a lot of years, and maybe even are still doing that. And so maybe it's voiding, maybe it's the backing materials. I'm not sure, but certainly that was a very disappointing false start for the LED lighting business.
I totally agree.
I've actually started putting the date on my LED lights when I put them in the ceiling, so I can start tracking that because I'm so curious about that as well.
Yeah, they start flickering. Next thing you know, you feel like you're in a disco, with strobe lighting. And my landscape lights all flicker. My indoor lights start flickering, and it's terrible. I'm doing the same thing. I'm saving receipts now and putting on the receipt where I put the bulb so I could take them back. But anyway, that's my little rant on that. Now could that be caused by voiding or maybe a million other things?
I mean, I
Certainly.
feel like if you're not extracting the heat, right? If you're not extracting the heat away from those products, then I think it would affect lifetime of the LED itself.
Yeah, and certainly voiding a complete solder joint does its job if the land is designed to be the right size, does extract the heat. So anyway, Tony, I think I took you off topic because I heard the word LED and I wanted to jump on that soapbox. So continue, my friend.
I'll chase you down the rabbit hole there. I'll follow you.
Yeah, exactly. Yeah, exactly.
Yes. So I have also heard that voiding causes issues sometimes with noise in a signal, especially if you're you have extremely sensitive instruments that you're building. We have customers that have reported that voiding is a real concern for RF circuitry as well, where it can interfere with the radio transmission and how that board is functioning. And so they're very concerned about that. And it's not necessarily heat that causes a problem, or even solder joint integrity. It is the noise that's created in the signals when there's too much voiding in those solder joints.
Oh, interesting. I hadn't heard that concern before.
Yeah, I think that's much more limited. That's not as popular, obviously, as automotive circuitry or LED lighting. It seems like everybody's building LED lighting nowadays because it's relatively simple technology. The boards are relatively simple. But I think there is something to be said for a well-designed LED board that does a good job of getting heat away from those LED components.
Sure. Well, from my perspective, soldering has at least three roles. One, very basic, it attaches the component to the board. It is the binder, the adhesive that keeps it from falling off when the board is subjected to shock and vibration. It allows the flow of current, obviously, to make the electrical connection. And it's a thermal dissipative material that will allow the heat to heat sink out of it and into the heat sinks, or the copper lands on the board, or wherever they're supposed to go, wherever the heat is supposed to go. So when the integrity of the solder joint is reduced due to voiding, due to insufficient soldering, then I would imagine all three of those things are affected, or at least potentially affected.
I would agree. Yeah, certainly.
Yeah,
and I think
too.
voiding has become a very popular topic in our industry, and a lot of people are talking about it. X-ray manufacturers are talking about it. Solder paste suppliers are talking about it, because we all have, solutions to that problem. We have solder pastes that are designed to minimize voiding potential. And I think oven manufacturers as well are in on that conversation, where they're designing ovens that can apply a vacuum during reflow in order to reduce voiding. So the industry's addressing it, but are we addressing it because there's an actual demand to address it, or are we propagating the idea that voiding is a problem because we want to sell more products? That's the question that I've heard people ask quite often.
Sure. Those darn X-ray people showing us stuff that we really didn't want to know.
Yeah. Out of sight, not of mind sometimes.
Exactly.
Or ignorance is bliss.
Exactly. Greg, I think I cut you off. You were about to say something.
No, you're good. From the stencil design perspective, just the other day I met with a large aeronautics company, and they're extremely concerned with voiding for long life expectancy, right? Things that may be in space for a long time, where they're carrying people. And the same in the medical industry. I mean, medical devices that are implanted in your body, that I guess, they want everything to be as perfect as they can get it. And so this push to reduce voiding on these type of thermal land pads is just, I think, being, it's being necessitated by those areas as well.
Sure, of course, particularly in the medical industry. Thank God we don't put LEDs inside of us, because every 6 months we'd be going back in to replace them.
Exactly.
Not to mention what happens when they start flickering. So your article talked about ways to improve voiding, reduce voiding, and I'm assuming it's broken up into at least a few categories. One is the design of the stencil itself, and Greg, that's your field of expertise. You're a stencil manufacturer. And Tony, you're the one that supplies the material that gets squeezed through those little apertures. And I'm sure that solder paste, I think you even mentioned solder paste technology, can help reduce voiding. And I'm sure also that the design of the apertures and the masking on the board, and there's other things that probably also contribute to a more successful reduction in voiding. So walk me through what your findings were in the article on how to improve the connection on these thermal lands on the bottom of these components.
Well, one of the big questions that we've had in the stencil industry for a long time, for years, has been, and maybe not addressed, has been the way you design a window pane, for instance. So the IPC guidelines recommend a window pane design to reduce voids.
And just for our, Greg, just for our audience, explain what a window pane is in case someone is not quite as close to this particular part of the industry as we are.
Yeah, so window pane would just take one large ground plane and then break that up into smaller squares with a web in between. And really, when you do that, it serves two purposes. One, you reduce the volume. If there's excess volume when you print solder paste underneath these components, when the paste goes liquid, there's an opportunity for the part to start skewing or floating. So if they're skewing during reflow, those perimeter pads can short or cause bridging, and then that you end up with a part that has to be replaced. So if we reduce the volume, we can prevent that skew and float during reflow. And then the other purpose that those window panes serve is to theoretically allow gases that are present during the reflow process to escape as that solder goes from liquid and freezes and becomes solid.
That's a big thing in the cleaning industry, by the way, is the entrapment of activators due to the lack of outgassing on a lot of these bottom terminated components, QFNs and things like that. The deal we have with no clean, for example, and Tony, this is right up your alley, is that all the bad actors either outgas and volatilize or are encapsulated in this rosin layer and kept in their little jail on the board. And in a lot of cases, when there's not the opportunity for proper outgassing, we end up with activators unencapsulated underneath the component, just ready to party and do bad things. So the idea of this window pane really addresses more than one concern. It addresses the concern you're talking about, which is voiding, and it also benefits from a no clean flux standpoint. If you're not planning on cleaning, if you're running a no clean and not planning on cleaning, then you just need to make sure that all the activators were either volatilized and removed or encapsulated.
Yeah, that's a great point, Mike. Certainly any kind of gas from the solder paste flux itself that's trapped in those solder joints could have active materials in it, certainly. And that could do some damage as that electronic device is used over a period of time.
So the window painting prevents the potential skewing of the component because it reduces volume. It allows outgassing, which provides all sorts of other benefits. What other mechanical or other techniques do you list in the article to reduce voiding?
So we looked at 4 different designs using a window pane pattern, right? We looked at the largest web. So let's say we have a solid thermal and we want to break that up into 4 smaller squares to print to, if we wanted to cover 70% of the area with solder, if we want to make that web as wide as we can, so we can push those 4 apertures or 4 solder deposits to the corners of the copper, was one of the patterns we looked at. We looked at just a standard design, which is kind of an industry accepted design for the window pane. We looked at the largest perimeter, so we made those the webs as thin as we could make them to maintain durability of the stencil. So you kind of bring that deposit to the center of the thermal. And the last one was just, we made as many potential panes as we could. So we just put as many webs as we could where we still, and all 4 patterns would still produce the targeted deposit percentage. So a coverage. So that was kind of the 4 areas we looked at.
Right. So the window pane is in the stencil itself and right. Not with masking material on the board. Okay. So what stops the solder from just, I imagine this very thin little piece of metal on the stencil to create the pane. So you have solder printed squares right next to each other with a small amount of separation. Once the reflow process starts, what stops all that from becoming one giant pad again? Does the solder not expand enough to reach the pane next to it and kind of close up the pane, or do they stay completely isolated and separated during the reflow process?
Tony, you want to talk about wetting and what happens with these patterns?
Yeah, certainly. Yeah, well, solder paste is designed to slump a little bit when it's heated, obviously. So it loses its brick shape and begins to flow like a fluid. And of course, we'll bridge the gap between those window panes. So our question is how far could that solder paste actually flow? Would the largest web allow complete flow of the solder paste and cover up the gap? Would the most panes design, would we be able to fill all the gaps in the most panes design? Because there's quite a bit of linear distance to gaps in that particular design. And then we reduced the paste area actually on these stencil designs, 80% coverage down to 50% coverage. And essentially, we were really challenging the solder paste to be able to see if it could flow and wet in all of these situations. Normally, the solder paste would fill in the gap, to answer your question. Normally, it would become one solid mass.
Mm-hmm. But does it stay separate? Is the concept to stay separated long enough to allow the outgassing before it forms one big mass? Or,
well, yes, part of the outgassing takes place during the preheat stage in the
right.
reflow,
okay.
Or during a soak in the reflow oven. You've got some slump occurring, but it's not enough to completely close those gaps. So you still have channels that are open for solvents and some of the activators to start outgassing and leaving that space underneath the component.
Right. And solder, I think, even though it does slump a little bit, it mostly forms a dome, mostly brings itself back in on itself, right? And increases the height. And
yes,
and the footprint of a might start off a little wider, and then I think by the time the soldering process, the reflow process is completed, the footprint might even be a little bit smaller than it was before. So that's probably maintaining the integrity of some form of gap to allow outgassing through the entire process. Is that a correct assumption?
Yes. Yeah. If you take some solder paste and just reflow it, say on a little piece of a circuit board on a hot plate, and you watch it, it begins to slump, and it, of course, the base widens out and it shrinks in height. And then when it goes liquid, it actually spreads out sort of into a pool, which it has a very low height. And as that solder melts, it begins to coalesce and pull back into the center. But the flux has spread fairly far relative to the solder itself. The solder pulls back, the solder metal, and then it does form a dome. So it reestablishes a height as it flows back together and assumes sort of a spherical shape almost. It wants to assume that sort of a form. And then that would essentially be separate from all the other bricks which are reflowing at the same time. And then as you continue to heat that above the liquidus point of the solder, that liquid solder then spreads back out again and merges with itself, merges with the next brick over, and so on, in order to form a complete solder joint.
Yeah.
So the more individual bricks you have there, the more individual window panes, the more potential there would be for the solder not to merge together. So you could almost design gaps or voids into that solder joint. There's a theory between solder paste suppliers that voiding is largely caused by wetting or incomplete wetting or flow of the solder rather than gas entrapment. Although gas entrapment still is probably the number 2 contributor, but those two things together are what really create voiding.
What would affect the wetting? That's an interesting concept. I can understand the outgassing. I can totally see where entrapped gases could not allow solder to flow. That's easy for my mind to see. Wetting is an interesting one, though, because one would assume that the entire land on the bottom of the component and the subsequent mating area on the board are all wettable surfaces. They've all had solder paste with flux in it applied. So is that a component issue? Is that a board issue in terms of solderability? If wetting is indeed part of the problem?
Well, we could probably do several podcasts on just that alone, Mike, to be honest with you, because wetting is a challenge for a lot of people. Wetting depends heavily on the surface finish, the age, and the condition of the surface finish. For example, if they're making the bare circuit boards and they don't rinse that properly at the final stages of applying the surface finish, there could be oxides or other chemical residues present there, which might inhibit wetting. The components themselves, if they're old, or let's say they've been open to the air for some time, the finishes that are used in the components can change in terms of oxide level and cleanliness. There are certain metals which are susceptible to oxidation, like immersion silver, for example, is susceptible not necessarily to oxidation, but any kind of sulfur in the air tends to contaminate the silver surface. It likes to react with sulfur and form silver sulfides, which is
a real problem in certain parts of the world. I know India has a real problem with air pollution, and sulfur is in the air and has all sorts of adverse effects, particularly with materials like silver and things like that.
Yeah, one of our recent series of papers was about how does surface finish affect solder paste performance. And one of the things we looked at was voiding with respect to the different surface finishes and solder paste combinations. And there is quite a difference in voiding performance just based on wetting or spread of the solder paste on that finish itself.
Interesting. So we have one way to improve voiding, to reduce voiding through stencil design, window painting, for example. What does the solder material, bring to the table with regard to reducing voiding, and either through whatever mechanism is causing the voiding? So, for example, wetting or any other aspect. What do solder paste manufacturers bring to the table that would markedly reduce voiding compared to another type of paste, for example?
Well, solder pastes, as you know, are comprised of solder powder, solder alloy, which is the majority of what's in it, and then a flux. And the flux is really where our technology is. That's our secret formula with all the magic built into it. But the solder alloy plays a role. For example, tin lead wets and spreads farther and more evenly across most surfaces than lead-free alloys. And that's partially due to, just the physical properties of the solder itself and its behavior when it is in liquid state, but it's also due to the rate of oxidation of those alloys. Tin lead is naturally sort of the oxidation potential of that is retarded a little bit because of the lead that's present, and it's reflowed at much lower temperature than lead-free alloys. Lead-free alloys, which are largely based on tin, are susceptible to oxidation more readily than tin lead solder. And so the oxide that builds up on that solder takes some of the extra power or activity of the flux to deal with, and then the flux doesn't have as much activity or potential to spread out on the surfaces of the component and the board pad. And so that itself, if you're using, say, heavily oxidized solder powder in your solder paste, that can consume all the activity of the flux, and it may not be able to help promote wetting or spread like you would expect on the board pad and the component leads. So that's one aspect. The flux chemistries vary pretty widely from one supplier to another. I mean, we all use similar ingredients in our fluxes, but fluxes are very complex formulations. They can contain anywhere from, say, 15 to 20 ingredients that are built into a solder paste flux and there's a specific recipe you follow in order to make sure everything's integrated and reacted properly. They're complicated to make, but there are ingredients you can use to minimize voiding potential. Like, for example, solvents maybe that are slightly more volatile or lower boiling point solvents that are going to evaporate off a little sooner during the reflow profile. Activators maybe that evaporate or don't turn gaseous, maybe activators that aren't volatile, that will be trapped in the rosin matrix and no cleans, and they'll be safe to leave on the circuit board, but they're not going to turn into gas. They're not going to, contribute to the potential for gas bubble type voiding. Those are the kinds of things we can change in solder paste formulations in order to minimize voiding potential.
Very good. Are there just general rules, regardless of the paste that they're using, that would positively affect voiding? For example, how solder pastes are being stored, how long they're being used before cleaning the stencil printer and putting new paste in, the temperature they're being stored at. Can a solder paste which has good voiding stats become bad over time and exaggerate exacerbate the voiding problem? Is there just a good best practice that for any kind of paste that would land on voiding?
Yes, certainly. Thank you for bringing that up. solder pastes are susceptible to change once you open them to the air. Obviously, you can get some solvent evaporation slowly out of the solder paste. Air oxidation can occur to the solder powder inside of the solder paste itself. And also you can sometimes get moisture absorption from the air into the solder paste, which is especially a problem with water-soluble solder pastes, which tend to be hygroscopic. So they like to absorb moisture out of the air over time. Some of them are so aggressive at that they can actually become soupy while you're printing them. And of course, any moisture that you're adding to the solder paste turns into gas during reflow and increases your potential for gas bubble type voiding. Where the best practice would be to, make sure you warm your solder paste up to room temperature before you open it. If it's cold, you pull it out of the cooler and you open it immediately. That will act like a glass of ice water on a hot and humid day, where there'll be condensation occurring in the solder paste itself, which is a bad thing. So the solder paste should be warmed properly before you open it. When you put it on the printer, you should try to use it without pauses continuously. Now, I know that's not always possible for lower volume manufacturers, but if the paste is going to be out for a time without being used, the best practice would be to scrape it off the stencil and put it into a separate jar and seal it while it's not in use. So try to keep it away from the air as much as possible. And then if the solder paste is aged, like if it's a little older in its shelf life, I've always tell customers this: solder paste quality never gets better with time. It's not like wine, it doesn't age well.
Right.
The solder paste just gets worse over time. It loses activity. Print and reflow characteristics degrade over time. So best possible voiding is probably going to be achieved with fresher solder paste.
Sure.
So if someone's having a voiding problem and the paste is near its expiration date, I would recommend trying a fresh version of that same paste. That might help.
Yeah, absolutely. So Greg, on stencils, I'm going to ask you kind of a similar question. Is there a best practice routine that apply to stencils that would help reduce voiding or any other solder paste failure? And what I'm thinking of is frequency of cleaning the under wipe process, in process in the stencil printer, or taking a stencil out and cleaning it, putting it back in, or nano coatings or anything like that. Is there any type of practice, a best practice that customers should follow, that your customers should follow to improve the yields and the quality of the printing process relative to the stencil?
Yeah, well, let me back up just a little bit on this paper. We've talked a little bit about stencil design already, and these different window panes that we can use. What really drove us to write this paper and do this research was that in previous papers, and Tony, I think you'll agree with me, we've changed and looked at multiple different designs, but we've always kept the area that we covered or the volume that we applied the same. And what we saw is that when we kept that volume around, let's say 65% coverage. So if we cover 65% of that thermal pad with solder paste using a window pane design, and we look at 4 or 5 or 6 different patterns, we really didn't see a difference in voiding by just changing the pattern while we kept the percent or the coverage volume the same. So in this paper, we looked at a combination of patterns and volumes from 50% up to 80% coverage. And what we found is that a combination of both the best pattern to use with a window pane and these higher volumes, like 70 and 80% coverage, produced the lowest voiding results. So that was kind of the end, the take home, I guess, if you will, of the paper was that if we can cover 70 to 80% of that thermal land pad with the correct window pane, then that really maximizes voiding. And it was statistically the best when we looked at those different variables. So as far as design goes, those two combinations were the best. So in the past, we've always recommended a 60% coverage. And after this work, our company will start recommending a 70 to 80% coverage design.
Interesting.
So, as far as voiding.
More coverage, less voiding with window pane.
More volume, less void. Yeah. And as much volume as you can get without getting this starting to get this skew and float of the component during reflow, right? So.
Yeah, actually, I had an experience with that recently with a customer who was having a voiding issue on a particular QFN component. And they tried increasing the printed solder paste volume by adding a step to that particular component. And that helped dramatically reduce voiding on that particular component. And they wanted to reduce it a little further, so they tried to increase that thickness even by an additional mil in the step and reported excellent results with it. So stencil design can certainly have a large impact on voiding. Yeah,
that's what it sounds like. So Greg, best practices for stencils in general, not necessarily related to exclusively to voiding. What would be in your world? What would you like all your customers to do with your stencils? How should they process them? How often should they be cleaned? How should they be cleaned? How should they be handled? What materials do you recommend in terms of how they're made? Tell me in your world, what would be nirvana for your customers and for you?
Well, we did a paper a couple of years ago where we were curious about, so stencil manufacturers have choices of the stainless steels that they can use. So we looked at 7 or 8 different stainless steels from different vendors across the country, and we're able to identify that some stainless steel manufacturers produce stainless steel materials that just cut smoother and better, more accurate with the fiber lasers that we use in today's stencil manufacturing world. So if those particular materials are used, one of the materials that you hear a lot of stencil manufacturers talking about is fine grain materials. And so that definition was fairly loosely used, and we have attempted to kind of define what a fine grain stainless steel is. But in that paper, we also found that some fine grain, quote unquote, materials didn't perform as better as other fine grain materials. So it's really important that the stencil manufacturer or the end user make sure that they're getting the best product in the market. And of course, we all kind of hold those, we kind of all hold those manufacturers like close to us and don't necessarily release whose product we're using.
Of course.
But as far as, day-to-day usage of the stencil, one of the most important things I feel is once the stencil has been used, you've printed the product, before that stencil gets put back on the shelf, it's extremely critical that stencil be completely cleaned of solder product. So if there's solder paste left in these apertures and you put that stencil on the shelf and it's 6 or 9 months or 2 years before you run that product again, I mean, that solder paste just turns to like almost concrete in those apertures. And then it's almost impossible to get out from my experience. Maybe from your experience, you have a good product to get that out, Mike.
No, they're well, yeah, put it in the stencil cleaner for 10 hours or something. And then, and then the adhesive bonds start breaking down. No, the best from a cleaning standpoint, obviously clean frequently and often and within a short time from contaminating the product. That can be applied to anything that needs to be cleaned, whether it's dishes or stencils. What about nano coatings? I know we're getting a little bit off track here, but I think there was an article on your website, Greg. I don't remember if it was written by you or somebody else, but about the nano coatings. Do they help to reduce the frequency of cleaning, or do they just help with the cleaning process? Do they help with the transfer of solder, that it's a cleaner print? What are the advantages of nano coatings?
Do you have another couple of hours we can talk about?
Sure. This is the Jerry Lewis telethon of solder best practices in solder printing.
Here's what I usually tell customers. There's really 2 types of nano coatings available in the S&T world today. There's one that's just a wiped on version. And it's applied to the bottom of the stencil. It's clear. It's just a few nanometers thick. And that product prevents solder paste from sticking to the bottom of the stencil when the stencil and the board don't have a perfect gasket, right? So which fairly rarely happens. So if you can imagine, the stencil comes down, gaskets to the board, the squeegee squeegees paste and fills those apertures. If the gasket is not perfect, you'll get some squeeze out between the bottom of the stencil and the top of the PCB. And so when that separates, when the stencil separates from the PCB, if there is not a coating, a little bit of that paste will stick to the bottom of the stencil. And the next print will be a little bit worse, next print's a little bit worse, until the stencil cleaner or the operator cleans the bottom of the stencil and that process starts again. So when you apply any kind of a coating to the bottom of the stencil, it prevents that from happening. So a lot of customers can, instead of cleaning every print, they can clean every 3 to 5 prints or 5 to 10 prints. Really depends on their process. But so one of the coatings is a wipe-on coating. It's clear. You can't really tell if it's there. And the other coating is a sprayed-on, baked-on. Our product is NanoSet Gold, but it's a sprayed-on, baked-on ceramic-type coating that actually coats the bottom of the stencil and the aperture walls. So, and if you look at an SEM photograph, you can actually see it present in those walls. But both coatings prevent the paste from sticking to the bottom, improve cleaning frequency. But the sprayed-on, baked-on ceramic-type coatings are really the coatings that have been proven to improve transfer efficiency for small area ratio printing. So if customers are looking to stay, let's say, with a 4 mil stencil, but they have area ratios down in the 5s, and there's a regular stencil just will not release solder paste, the addition of these ceramic nano coatings can allow that solder paste to go ahead and release and give you good print deposits.
Sure. So it has all sorts of applications and benefits.
Exactly.
It's funny.
Well, I'm sorry. Go ahead.
No, go ahead, Greg.
As far as cleaning goes, when you start to use those products, either one of those two products, any nano coating, then you have to be really careful with the cleaning process that you use. So a lot of the stencil cleaners that have been on the market a long time that are highly alkaline can actually remove or reduce the benefits of those coatings.
Right. You want to be as close to neutral as possible, I would guess.
Exactly. I mean, we say a pH neutral cleaner at room temperature probably is the best combination for a cleaning process. Yeah.
Well, when it comes to cleaning, high pH tends to work for post reflow. I'm not talking stencils. I'm talking circuit assemblies, because the whole saponification process works by the high pH chemical reacting with the acids in the flux to convert it to soap to make it water soluble in the rinsing process. For stencils, nothing's been reflowed. It's a lot easier to clean non-reflowed solder paste than reflowed solder paste. So you don't need those high pH attributes that you would in a post-reflow application. And there are pH neutrals for post-reflow as well. They are very effective when they are very effective. They are not when they're not. But in the cleaning of stencil world, certainly 7 on a pH scale or 7.5 or anything around there is safe on the stencil, safe on the operator, and safer to dispose of if one is disposing of the solution, and just as effective as the high pH. That's been my experience anyway. So I totally agree. You know, it's funny with nano coatings. The first time I heard about nano coatings was several years ago at one of our industry's conferences, and they're talking about the benefits of nano coating on stencils for all the reasons that you had already outlined, Greg. And then probably 6 months later, my car detail guy, I get my car detailed twice a year, just put coat of wax on it. I live in California, so we don't have a harsh environment, but the sun can be a harsh environment. So I have my car waxed twice a year. And he came up to me and he goes, Mike, I've got this great new product. I'm like, okay, what is it? He goes, well, it's expensive. It's $1,500. I'm like, what? Are you repainting my car? And he goes, no, it's called nano coating. And that technology has made its way into the consumer markets now with car waxing technology. And he says, I can do your car for $1,500 and I don't have to detail it for 3 more years. I was like, well, that's why you're charging me $1,500, because you're not coming back. And then I started noticing it land in like really consumer products, like turtle wax now with nano coating and or whatever name they called it, but it was all the same technology. And I just thought it was funny how it learned about it earlier through the high technology world, the electronic assembly world, and it was applied to stencils, and then it was only the best car detailers have it, and then it ended up on a shelf at the local supermarket in a turtle wax jar. It was just funny to see the transition of that type of technology. Let's kind of wrap this up. Any more talk about voiding? Did we miss anything that the article had in it, or from your vast experience?
Well, we've actually done a lot of work on voiding over the years, as many of our counterparts in the industry have, and it's a complex issue. There are a lot of different potential causes for voiding, so there's a lot of potential solutions for voiding. And what I'm finding from talking with customers on a daily basis is when they have a voiding issue, they generally are trying everything they possibly can to solve it. They'll try stencil design, they'll try switching solder pastes, changing reflow profiles, and if they have to resort to this, they will rework components in order to minimize voiding in a solder joint, and that's a crapshoot. That's hit or miss whether that is going to work or not. And so it's a challenge. What I've found is the one sure method of reducing voiding is doing all of that. But in addition to that, honestly, vacuum reflow systems are the way to go. If you're having a real voiding problem and it's going to continue to be an issue, it might be worth investing in that type of equipment in order to make sure that you're giving your circuits the best possible chance at having low voiding.
Yeah, I was just speaking with David Heller of Heller Industries earlier this week for an upcoming episode. In fact, by the time people hear this episode with David Heller is the one before this one. If you're hearing this now, just go back one episode and you'll hear that one. And he talked about voiding as well, and the vacuum processes to reduce the voiding. That's the second time in 1 week I've heard that, Tony.
Well, I think that works regardless of all those other factors. So vacuum and reflow is going to help regardless of what solder paste or what stencil design you're using or the circuit design, the components, it's going to help in all situations.
Tony, is there a particular type of flux? I throw fluxes. I know IPC has their new flux categories, which are many, but I throw fluxes into three categories, the age-old categories. They're either rosin fluxes like RMAs or RAs. They're either water-soluble fluxes, which we all used to call OA, organic acid, or they're no-cleans. Is there a particular solder paste type, rosin-based, water-soluble, or no-clean, that just because it's that flux is better at voiding? Is it easier to solve a voiding problem with one of those species of fluxes than the other?
I believe that the no cleans, the newer technology no cleans, are going to have a lower voiding potential than the other types of fluxes. And it seems that the water solubles usually have the highest voiding potential. And that's largely due to the obviously the chemistry is quite different, but water solubles have relatively low solids contents in the flux compared to no cleans and rosin fluxes. And the lower solids content means there's more solvents present. And so there's more potential for gas bubble type voiding with water solubles. So no cleans today, though, are highest performing solder paste. Probably the most R&D has been done on no clean lead-free solder paste over the last 15 years. And so those are the best performing products. Also, from a voiding point of view, they're typically the best performing products. I think solder paste kind of sets the baseline. So whatever solder paste you're using, there's a certain potential for voiding. And then you can obviously change that. To change the potential for voiding, you can buy lower voiding solder paste. But then if you're still having a voiding problem of low voiding solder paste, then you've got to start looking at those other factors that I was talking about, right. Stencil design, reflow profile, and maybe rework if necessary.
Yeah, if voiding is a concern, start with a low voiding solder paste, so at least you have your best chances. And then the mechanical changes in design and process will help take you the rest of the way, hopefully.
One thing we should mention is board design often plays a big role too. What we've seen is a tendency for via holes to be placed in thermal pads on QFN components, and via holes themselves lead to a whole different type of voiding that can occur. So there's ways of addressing that I think the bottom terminated component standards development team is working on. You can plug those vias. You can put solder mask dams around the vias so solder can't flow down and maybe gases can't come out of the via or other trapped materials can't come up into the solder joint. And so via and pad designs are a whole nother ball of wax, pretty much. It's like you're playing a different game with voiding when you've got that situation.
Sure, but people who lay out boards are generally not the same people who assemble boards. I just had an interview with Judy Warner of Altium, and their business is all about the design of a circuit board, the layout of a board, and there is a huge disconnect between the folks that design boards and fabricate boards, for that matter, and the people who assemble them. And there, just as there's a huge disconnect between people who design and manufacture components, and the folks that have to figure out how to place them and how to place them successfully. It's a huge disconnect between all the players in our industry, and we're handed something. Bottom terminated components, for example, we're handed these things, which are great from a packaging standpoint, but it's kind of up to us now to figure out how to actually solder them and how to solder them reliably. Even though they're great packages, they just weren't quite ready for prime time. So when we're handed the package, we're not handed a list of instructions like, okay, window pane the stencil and block the vias and things like that. We just have to kind of figure that out as an industry.
Yeah, I totally agree. And that's where Greg and I come into play with our customer base, because they don't have control over the board design or the components, and they just have to solder it and make it work. And so the things they can change are stencil design, solder paste, reflow profile, right? Those are the easy things to change. And that's where we've focused our efforts, obviously, because we work for companies that supply those products. But we definitely feel their pain when voiding is a concern. We try to help in any way we can. And it's like you said, they're sort of handed this kit of parts sometimes, and okay, make this work, make it function properly.
Exactly. Reminds me of the Apollo 13 scene where the folks in mission control threw a bunch of things on a table and said, okay, whatever the solution is has to involve these parts because that's all they have up there. And
right, like a pencil, a paper cup, a little filter, right? Exactly.
Yeah. Well, you guys are your industry, and you guys probably specifically should be wearing capes. You're the superheroes of this particular issue of voiding, because as we just said, your customers are given these tools and these requirements, and you guys have to figure out how to make it work reliably. So thanks for that. I appreciate your willingness to be on the show and to share your expertise on not just voiding reduction, but best practices in stencil design and solder paste selection and processes. I really appreciate it. Anything else you guys want to add before we wrap this up?
Yes, actually.
I do want to add
a little pitch.
Go ahead, Tony.
Yep. Can I make a little pitch for a project Greg and I are working on right now, which has to do with the same topic? Actually, it's sort of part 2 of what we were talking about today, Mike.
Absolutely.
We are working on a paper for IPC Apex in 2020 that is really a practical approach to reduction of voiding. So we're looking at additional stencil designs for bottom terminated components, solder paste, and reflow profile changes to minimize voiding, just from a completely practical point of view.
But wait, there's more.
Exactly.
If you order in the next 10 minutes, we'll double your order. That's great. So that you're going to present that at Apex 2020, which is at the very beginning of February, right after Super Bowl, as I understand it. So for those that are coming to San Diego, that would probably be well worth your time to listen to these two present even further information on how to reduce voiding.
Yeah, sorry, Greg, I interrupted you. What were you going to say?
Exactly the same thing you said.
So very good, and you're gonna present that. That'll be a paper. Your paper, by the way, will be in our show notes. So for our audience who have heard us talking about the paper, Root Cause Stencil Design for SMT Component Thermal Lands, that link to that paper will be in the show notes, so be sure and look that up. And we'll also put contact information for Tony and Greg, so that if you have any questions, I'm sure they will be very pleased to respond to you. And both of you, thank you for being on the program. I really appreciate it.
Well, thank you for having us, Mike. We appreciate the opportunity to be on your show.
Yeah, Mike, thank you. Thanks for having us, and looking forward to working with you more.
All right. Well, my pleasure. Thank you guys very much. Well, that's another episode. Thanks for listening to the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on iTunes, Spotify, iHeartRadio, or wherever you get your podcast. Reliability Matters and other reliability-based podcasts are available at Circuit Assembly's PCB Chat at pcbchat.com and at Ascendo Reliability at reliability.fm. Thanks for your comments. Please keep them coming. Send comments and episode suggestions to Mike at mikeconrad.com. That's Conrad with a K. Until next time, thanks for listening and keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.